All right, let's jump right in. Welcome to this explainer on simple index numbers. Today, we're going to break down exactly how economists measure changes in the economy using literally the most straightforward tool in their toolbox. If you've ever wondered how we mathematically track massive shifts in things like general price levels or agricultural production over time without getting completely lost in the weeds of complex data, well, this is exactly where it all begins.
Here's our roadmap. We'll kick things off with the equal weight approach, then systematically stack three calculations: the simple price index, the simple quantity index, and the simple value index. Finally, we'll wrap up by looking at the limits of all this simplicity.
Okay, part 1, the equal weight approach.
Let's establish the absolute golden rule of this entire framework. Imagine a series of diverse commodities. Let's just call them A, B, C, and D, sitting side by side on a perfectly balanced scale. In the simple index method, that scale applies the exact same weight to every single item. This means every good is treated with absolute equal importance, completely ignoring real-world consumption habits. It's the easiest method out there precisely because we don't have to stress over which item is more popular or essential. On the spreadsheet, they are all perfectly equal.
Before we actually start crunching the numbers, you've got to know the key notations. It's kind of like a secret code, but it's really straightforward. We use suffixes to tell our years apart. The suffix 0 is our base year. Think of it as our starting line in the past. The suffix 1 is our current year, the one we're looking at right now. So a lowercase p0 is the price in the base year, while p1 is the price in the current year. Same goes for quantity. Q0 is base year volume and Q1 is current year volume. Keep those in your back pocket.
Moving on to part 2, the simple price index calculation.
Thinking about our data, we've got our four equal weight commodities, A through D. We track their prices in our 2010 base year, that's P0, and we track their 2015 current year prices, P1. Because this is a simple aggregative index, the math is a total breeze. We literally just total up the columns. Summing up those base year prices gives us an aggregate of 220. Then, summing up the current year prices gives us an aggregate of 300. Now here is the crucial rhythm we're going to repeat today. 3 simple steps. Sum the base column, sum the current column, and apply the formula. It's a highly structured, totally reliable way to process this kind of data. And bam, here's that bold formula springing to life. To find our price index, which we call P01, we simply divide the sum of our current prices by the sum of our base prices and multiply the whole thing by 100 to make it a percentage. So 300 divided by 220 times 100 gives us a final price index of 136.36. This tells us clearly and instantly that, yep, there's been an upward trend in the general price level for this specific basket of goods.
All right, part 3, the simple quantity index calculation.
Now, shifting gears from prices to physical volume. The data now tracks quantities instead of prices. We've got our base quantities from the year 2000 as Q0 and current quantities from 2001 as Q1. Just like before, we total them up. The sum of our base volume is 210 and our current volume is 280.
And we're sticking to those exact same mechanical steps to keep the cognitive load nice and low. Sum the base volume, sum the current volume, and get ready to divide.
The quantity formula here, Q01, follows the exact same structure as the price formula, we just swapped the P's for Q's. Plugging in our totals, we take our current volume of 280, divided by our base volume of 210, and multiply by 100. That reveals a quantity index of 133.33, showing us the relative percentage change in the physical volume of these commodities.
Next up, part 4, the simple value index calculation.
Finally, we're bringing price and volume together to calculate overall value. For the base value, we multiply the base price by the base quantity, so P0 times Q0. For the current value, it's current price times current quantity, P1 times Q1. When we sum these up, we get a total base monetary value of 100 and a total current monetary value of 880. For the third and final time, we apply our trusty scaffolded logic. Step 1, grab the base monetary sum. Step 2, grab the current monetary sum. And step 3, apply the ratio. And here is our value formula. V01, total current monetary value divided by total base monetary value multiplied by 100. We divide 880 by 100, multiply by 100, and we get a massive value index of exactly 880. That completes our mechanical calculation. See? Just by knowing how to add up columns and run a simple ratio, you can measure absolutely massive macroeconomic shifts.
Which brings us to part 5,
The limits of simplicity.
Okay, so we've completely mastered the math, but what's the real takeaway here? Well, there's a pretty huge catch. This simple method is incredibly easy to calculate because it assumes every commodity is sitting on that perfectly balanced scale we talked about earlier. It gives equal weight to everything. But come on, that sharply contrasts with reality, right? In the real world, we don't value every item equally. A huge spike in the price of wheat is going to impact an economy way more drastically than a spike in the price of a luxury watch. Yet this simple index treats them like they have the exact same impact.
And that perfectly highlights the limits of this basic spreadsheet math, leaving us with a really critical question. If simple index numbers treat a basic ballpoint pen and a brand new car as equally important to your wallet, how do we adjust these formulas to reflect reality? Well, to do that, we'd have to step into weighted index numbers, where we finally tip the scales and assign true proportional importance to what we actually consume. Keep that in mind the next time you see a headline about inflation or economic output.